Okay, looking at the auxiliary angle method. So first of all, what we're going to do, like part one here, we're going to express sine theta plus cos theta in the form of r sine theta plus alpha. Okay, so we can do the longer way where we expand this theta plus alpha is r sine theta cos alpha, because sine goes to sine cos, plus r cos theta sine alpha, and then you just match this stuff up so to form your triangle. Okay, but the quicker way is probably just to go straight to the triangle. So you can see, like here, the sine thetas match up, the cos thetas match up. The number in front of those, that's what r cos theta would equal, and alpha will equal. So cos alpha is 1 on r, and sine alpha is 1 on r. So if you had your triangle, there's r1, 1, and alpha. So you could just go straight to your triangle. Now the way to remember your triangle, instead of deriving it like this each time, the way to remember your triangle is the fact that if you've got sine theta plus cos theta, that's 1 in front of there. This is A equals 1 and B will equal 1, and your triangle will be AB alpha, okay, and this will be R. R is the number in front of the sign that's here. So remember A for adjacent. So if that's alpha, then tan alpha is 1 on 1. So alpha is tan the minus 1 of 1, which is 45. And r squared is 1 squared plus 1 squared. So r squared equals 2, so r is root 2. So expressing that in the form of r sine theta plus alpha is root 2 sine theta plus pi on 4. Okay, hence solve that equation. Okay, so I'm going to do the hence part. So that means root 2 sine theta plus pi on 4 would have to equal, now the number on the right hand side there is 1. So then you divide by root 2, so sine theta plus pi on 4 equals 1 on root 2. And then you need to solve that equation. I'm just going to move this one because it's in the way. I need a little bit more space. Let's put that down there. Okay, so sine equals 1 on root 2. That would be a positive. So where is sine positive? All stations to cos. Then that would be positive in that quadrant and that one. So that means it's theta, and it is 2 pi minus theta. So the acute angle here, it would be as if you go sine the minus 1 of 1 on root 2, which is 45, or pi on 4. Do that again. Okay. So looking at that now, that means that this angle here that we're solving for, which is your theta plus pi on 4, will equal theta and 2 pi minus theta. And that theta there is just your acute angle here. So it's theta plus pi on 4 equals pi on 4 and 2 pi minus pi on 4. If you subtract pi on 4 from both sides, you've got to subtract it from each of these. Then theta would be, the pi on 4 minus pi on 4 is 0. This is 2 pi minus 45 and 45, which is 90. So 2 pi minus 90, that would be 0. That would be 3 pi on 2, or 270. Now, you have to be careful that if you do get 0, or you get a negative angle, that you get the other. If you get a negative, you have to get the positive, so you take away from 360. But if you get 0, you must also include 2 pi in your solution. Okay, so the next step that we need to do here, let's look at this. So the first part is express cos theta plus root 3 sine theta in the form of r cos theta plus alpha. Okay, so that means that if you draw up your triangle, there's alpha, your adjacent is the one in front of the cos, and your opposite is the root 3. So that's 1, opposite is root 3, that's your A, and that's your B, that's your R. So the R would be R squared is 1 squared plus root 3 squared, which is 4. So R is root 4, which is 2. And tan alpha is root 3 on 1. So alpha is tan the minus 1 of root 3. That's 60 degrees or pi on 3. Okay, so now expressing it in that form, r cos theta plus alpha, that would equal 2, because that's your r, and then your alpha is pi on 3. So it's 2 cos theta plus pi on 3. Notice that with cos, you've got a minus in the middle, it would be a plus there, okay? But when we did the sine one, when it was a plus, you notice it was a plus. So the sine keeps the same sign when you expand, but the cos one is different. Okay, so the second part says, hence you've got to solve this. So hence means you need to use what you did previously in order to solve it. So we can replace this part here with what it equals, because it's in a simpler form. So it's 2 cos theta plus pi on 3 equals 2. Divide both sides by 2. That's cos theta plus pi on 3 equals 1. All right, so you get the acute angle. So that's theta plus pi on 3 equals 1. Now, when is cos equal to 1? So cos is equal to 1 here at 0 and 360. And if you think about it like this way, see, where is cos equal to 1? That would be 0 and then 360 or 2 pi. So it's going to be 0 and 2 pi. So now we need to take away pi on 3, take away pi on 3 from both sides. So they'll cancel out and you get theta equals minus pi on 3 and 2 pi minus pi on 3. Theta equals minus pi on 3, and if you times that by 3 to get the common denominator, that'll be 6 minus pi. So it'll be 5 pi on 3. Because that's 6 pi on 3 minus pi on 3, 5 pi on 3. And there are your two answers. There's a bit of a problem with this one here. That's minus 60. So minus 60 is the same as 360 minus 60, which is 300. 300 pi on 180, when you simplify that, is actually 5 pi on 3. So you get the same as this one anyway. So there's only one solution here. Let's move that down. So the one solution is theta equals 5 pi on 3. Let's fix my 5 up. Okay, and finally, this is my last example. This one, we're going to do this in degrees. So express this, so you got cos theta plus 2 sine theta. We're going to express it in the form of r cos theta minus alpha. Where is, sorry, not doing that yet. We've got the triangle happening, so we go alpha, A is 1, B is the 2, and that's the R. So R squared is 1 squared plus 2 squared. R squared is 5, R is root 5. And tan alpha is 2 on 1. So alpha equals tan the minus 1 of 2. So now let's just get, that will be the acute angle of that. If you went shift tan of 2 is 63 degrees 26 minutes. Now you can either put that into your memory, so shift, recall, it's the store button, M plus. So it's, you go shift, you go to the RCL and go M plus, because on the top of the RCL is a store button, so you're storing it. Okay, so once you've got that, it's going to be root 3, is it root 3? No, root 5, cos theta minus 63 degrees 6 minutes. You could also put it, if I wanted exact, it's minus 10 the minus 1 of 2. Okay, but there's your solution to the first part. The second part, hence solve this. So it's cos theta plus 2 sine theta equals 1. So in place of this here, you're going to put the above, root 5 cos theta minus 63 degrees 26 minutes equals 1. So cos theta minus 63 degrees 26 minutes equals 1 on root 5. Just remember this 63 degrees 26 minutes, exactly that would be tan the minus 1, shift tan the minus 1 of 2. Okay, so where is cos positive? Here and here. So that means it's going to be theta minus 63 degrees 26 minutes, which is theta and 2 pi. We're not doing 2 pi, we're doing degrees. 360 degrees minus theta. Okay, so what is the acute angle? The acute angle would be cos, because this part here is cos the minus 1 of 1 on root 5. Okay, so cos the minus 1 of 1 on root 5, so you go shift cos 1 on root 5. Okay, and I get 63 degrees 26 minutes. Again, to get the same angle, 63 degrees 26 minutes, 360 minus 63 degrees 26 minutes. So finishing that off, I have to add the 63 degrees 26 minutes to both sides. So I don't really want to add my rounded off answers, so you have a choice. You've either got that in memory, or you're doing tan the minus 1 of 2 plus tan the minus 1 of 2. We'll do it twice. And then it's 360. So this one we have to add 63 degrees 26 minutes. They'll actually cancel out. So you get 360. But if you get 360 as your answer, you must also put 0.